let's dive into the mysterious world of quantum computing. Imagine a computer exponentially faster and more powerful than the ones we use today. That's quantum computing in a nutshell. At the heart of it all are quantum bits, or qubits. Unlike classical bits that can be either 0 or 1, qubits can exist in multiple states simultaneously, thanks to a quantum property called superposition. This means a qubit can be 0, 1, or both at the same time, giving quantum computers a massive parallel processing advantage. Another critical concept is entanglement. When qubits become entangled, the state of one qubit instantly influences the state of another, no matter how far apart they are. This interconnectivity allows quantum computers to perform complex computations at unparalleled speeds. Quantum gates are the building blocks of quantum circuits akin to logic gates in classical computers. They manipulate qubits using quantum operations, enabling the execution of quantum algorithms. Speaking of algorithms, Shor's algorithm is a groundbreaking quantum algorithm that can factor large numbers exponentially faster than the best-known classical algorithms. Why is this important? Because it has significant implications for cryptography and internet security. Currently, quantum computing is still in its infancy, with major tech companies like IBM, Google, and Microsoft developing prototype quantum computers. Quantum supremacy, the point where quantum computers outperform classical computers, has been achieved in specific tasks, but we still face challenges like error rates and qubit coherence. Quantum computing has the potential to revolutionize fields like cryptography, material science, pharmaceuticals, and even artificial intelligence. Now that you have a grasp on the basics of quantum computing, you're ready to engage in conversations about this fascinating frontier of technology. Like and subscribe for more videos like this. Stay curious and keep exploring.